Okay, good morning. Welcome to
Fun Math number 63.
Fun Math number 63. Yesterday we did angle on a clock at an easy time, and I unfortunately don't remember what time that was. Today we're going to do a more complicated time. I'm going to let you pick it. Pick a time, but don't pick 4 o'clock or 5 o'clock. Pick a
relatively complicated time.
Pick a mediumly complicated time. Don't pick 9:23.67 seconds or something. Okay, what's a good time?
How about, let's do 12:20.
Okay, 12:20. Okay, the angle on a clock at 12:20. Okay, let me quickly draw a clock. Okay, so here's 12, 3, 6, 9. Okay, could you please draw for me the angle? Sorry, there's a little bit of goop in the middle of our clock. Please draw for me the hands at 12:20. Where's the minute hand?
The minute hand's here.
Okay. And where's the hour hand?
It's about right there.
Okay. So the hour hand is in between the 12 and the 1.
Yeah.
And the minute hand's pointing right at the 4. Okay?
Yep.
Not too bad. Now how are we going to figure this out? How are we going to figure out the angle that the clock is making here? I'm going to just adjust. It looks like your hour hand is the minute hand, so let's make that just a little shorter. So we know that's the hour hand and this is the minute hand. So this is 12:20.
Well, at 12 o'clock, it's a 0-degree angle.
Okay, great. At 12 o'clock we have a 0-degree angle because the two hands are right on top of each other.
Yeah.
Okay, and what happens in the interim between 12 and 12:20?
The minute hand moves down.
Okay.
How many?
Well, that's all right. The minute hand moves down this way. What does that do to our angle?
It expands the angle.
Okay, so the minute hand starts up here, and moves this way and makes the angle bigger. Okay. What happens to the hour hand?
The hour hand moves the same way but slower.
Okay, it moves the same way, it's slower, and what does that do to the angle?
Shrinks it.
Shrinks it a little bit. In comparison to if the hour hand stayed still, the angle would get really big, but since the hour hand's moving, it doesn't get quite as big.
Yeah.
Okay? So that's good. So now the first thing is how fast is the minute hand moving? How fast is the minute hand moving? And I know you probably know the answer to this, but I want you to explain how you find the answer to this.
Well, the distance it's moved is four wedges.
Okay.
And each wedge is 30 degrees.
Each wedge is 30 degrees. Okay, why is each wedge 30 degrees?
There's 12 of them, and there's 360 degrees in a circle.
Okay, there's 360 degrees in the circle. There's 12 little wedges in between the 12 numbers. Okay, so each wedge is 30 degrees. Okay?
So it's traveled 4 wedges, which is 120 degrees.
Okay. It's traveled 120 degrees, but that doesn't still tell me how fast it's moving. I wanted how fast it's moving in degrees per minute. Okay, it's traveled 120 degrees.
How many minutes did that take?
Okay.
Well, there's little tick marks in there.
Yeah, there are, but that's okay. How many minutes did it take to move 120 degrees?
Each of these is 5 minutes.
Right.
So 20 minutes.
Okay, good. 20 minutes. How could we have figured out that it took 20 minutes pretty fast?
There's 4 wedges.
Well, how else? What time are we looking at?
12:20.
12:20. Okay. So it took 20 minutes. And so how fast is it moving in degrees per minute?
We can cancel these zeros. It's 6 degrees per minute.
Okay, so the minute hand moves 6 degrees per minute. Okay. The easy way to know that is what?
It's just
What's the easy way to calculate how fast the minute hand moves?
Well, it moves 30 degrees in 5 minutes.
Okay.
So you can just do that.
Even easier than that. What's the easiest distance in angles that you know the minute hand goes?
It goes 360
In how long?
in 60 minutes.
It goes 360 degrees in 60 minutes. So that's, you can,
360 over 60.
6, which is 6. Okay, so the minute hand moves 120 degrees in 20 minutes, or 6 degrees a minute. So we have plus 120 degrees from the minute hand. Now we have to figure out how far the hour hand move. But first, let's figure out how fast the hour hand is moving in degrees per second.
Minute.
Yeah, sorry, degrees per minute. Okay, degrees per minute for the hour hand. How are you going to figure that out?
Well, each of these is an hour, so it moves 30 degrees in an hour.
It moves 30 degrees in an hour.
30 degrees for every 60 minutes, so half a degree per minute.
Okay, so it moves 30 degrees in an hour, 30 degrees in 60 minutes. 30 over 60 is a half, so it moves half a degree per minute. Okay, awesome. Now, so what's the angle now? How far did it move? How far does the hour hand move from 12 to 12:20?
It moved 10 degrees.
Okay, so what's this angle?
Well, we have 120 degrees. The angle, and it shrunk by 10.
Okay.
So it's 110 degree angle.
110 degrees. Okay. The minute hand made it bigger by 120. The hour hand shrunk it a little bit by 10. So it's 120 minus 10 gets us to 110. So that's the easy way to think through these problems, okay?
Okay.
Not super easy, but we just figure out how far this one moves, how far that one moves, and we take the difference. Okay?
Yeah.
Good job. Whoops. So much for that marker.